right, we're going to look at the bottom 4 questions on the second page of the study guide. So in 23 and 24, we're classifying triangles. So just a note here, you should always check first to make sure that that the 3 sides you're given make a triangle. So in your head, just run those numbers. Is 4 plus 5 greater than 6? And we know it is because 9 is greater than 6. So now we're asked to classify these as scalene, isosceles, equilateral, and acute, right, or obtuse. Well, first of all, if all 3 sides are different, that makes it scalene. But if I want to classify it as acute, right, or obtuse, I have to consider how a squared plus b squared compares to c squared. When a squared plus b squared is greater than c squared, that's what makes it acute. When they are equal, I'm just writing this out to the right, when they're equal, that's what makes it a right triangle. And when c squared is the greatest, that's what makes it an obtuse triangle. So we do need to compare 4 squared plus 5 squared to 6 squared. Well, let's see, that's 16 plus 25, comparing that to 36. I could just do some mental math. I don't even really have to get this sum. I know 25, I would only have to add 11 to 25 to be at 36. So if I add 16, I'm definitely going to get a number greater than 36. So since a squared plus b squared is greater, that means that this is, that this is an acute triangle. So it is scalene and it is acute. 24, same thing. Check the smaller 2. So 8 plus 10 definitely makes a number greater than 10. So we kind of run it through this test, like, does it even make a triangle? Now, if I look, I have 2 sides that are the same. I know that it's isosceles. So now to determine if it's acute, right, or obtuse, we kind of run our test over here using the Pythagorean theorem. 8 squared plus 10 squared compared to 10 squared. Well, I don't really even have to do any of that math. If I'm adding 8 squared to 10 squared on the left, I know that's going to be bigger than just 10 squared by itself. So again, because a squared plus b squared is bigger, we have another acute triangle. All right, 25 and 26. These are problems with mid-segments. It's not important so much that you remember the word as you remember the properties. So I know that these are midpoints. So if I'm given that my mid-segment is 7, I can double my mid-segment, and when I double it, it's equal to the other side. So the other side has to be 14, the side that is 2t, that is parallel to the side that is 7. So if 2t equals 14, well, then that means that t has to be 7. All right. Number 26, same idea here. This mid-segment ZY is parallel to the side SQ, and therefore it takes 2 ZYs, 2 mid-segments, to be equal to that other side. So if I double that, I'm going to multiply x plus 2 by 2 and set that equal to 3x minus 8. Go ahead and distribute. 2x plus 4 equals 3x minus 8. Subtract 2x from both sides. And then add 8 to both sides. All right, and though if you want to check this one to see if you're correct, I could just plug that back in. Well, 12 plus 2, so x plus 2, if I plug in 12 for x, I get 14. If I plug 12 in for 3x minus 8, 3 times 12 minus 8, well, 3 times 12 is, what, 36? And 36 minus 8 is 28. And I know that SQ should be twice ZY. 14 times 2 is 28, so I know I did that correctly. All right, there'll be another video for the next page.